X chromosome. It is not an aberration of X chromosome, but it is because of gene mutation, the gene located on X chromosome.
But don't females have 2X?
Females X are, it is because it is X recessive. If for a female, she has 2X with the patient, with the disease mutation, with the disease gene. And for a male, because the male only has 1X, so if the gene mutation happened, he will get the phenotype. But for female, when 1X is abnormal and another X is okay, just a carrier. So the mother, always the carrier, passes down the gene to the boys and the girls. If the boy will if the boy get the recessive gene, he will be the patient. If get the dominant normal gene, he will be okay, healthy. But the girl, always just a carrier, because the girl, 1X from mother and 1X from father. The father is okay, so the X chromosome from father is okay. And the X chromosome from mother, if she get this one, it's okay. If get this one, carrier again. So pass the gene from the mother to the daughter and to next generation, maybe to the daughter's son, and will be the patient, and that's girl. Still a carrier. So in this kind of disease, in a whole family, you always see the patients are all male, no female, but female always the carrier. So when you are a consultant or your doctor do some consulting for the patient, give her a suggestion, do the prenatal diagnosis. It will be useful. Or just do the imaging to find the baby is male or female. If is male, do the diagnosis, do the molecular diagnosis. Okay or not okay. If a girl, okay. Just a carrier, no phenotype. Okay. The fifth characteristics is infectious. Do you remember I said the disease can invite to three kinds? The first one is infectious, no business of gene, but one special is prion disease. It is genetic and infectious. Do you know medical disease? So first, it is infectious. It can be passed from the mad cow with food, through eating the food. Prion is a normal protein located on the membrane, on the neural membrane. So everyone has prion, has normal prion. When the gene which encoding prion mutant, it will be a genetic disease. Passed from generation to generation. What happened the neuron? Degeneration. And it is also infectious when you get the mutant prion from the mad cow through your food, you will get the disease too. So it is genetic and infectious. Professor Prusiner is the scholar who did a lot of work on prion disease and get Nobel Prize in 1997, last century. In CK disease is also a kind of prion disease. Now it is always a genetic disease from one generation to the next. But in 1970s, last century, it is also an infectious disease. Because it happened always in this country, Papua New Guinea. And in that time, the tribe fight each other. And when they catch the animal, what they do? Eat them. idiom. So at that time, CK disease can pass from human being to human being by eating the animal. And now, prion disease always get from the animals by food or from the generation passed on. And the classification of genetic disorders. The first one is single gene disorder. It is because of one gene mutation. Look at this table. A lot of genes names. This is Chinese name, this is English name, and this is the gene location on which chromosome. In today's class, which I have mentioned, is single gene disorder like AIS, androgen intensivity syndrome, like the beautiful dancer who get disease and look like he is a male and look like a female. AIS is because of single gene disorder which encoding androgen receptor. And DMD, we have seen the video, and the patient look like when they walk look like a dark, very weak muscle because of one gene mutation, the gene encoding dystrophy. Encoding dystrophy. It is also because of single gene disorder. And albinism, white color with skin and hair. Also hemophilia in the Queen Victoria's family is single gene disorder. So single gene disorder is very important content in our course in this semester. And next time, David will introduce single gene disorder disease and its model. Chromosome disorders. The gene located on the chromosome. But chromosome disorders, it means chromosome, the entire chromosomes or large segments of chromosome changed, missing or alterated like that, duplicated. What's this? A baby? Scareful? It's scary. It's a baby. The baby has a disease named Patel syndrome. Patel is also a doctor who first reported the disease. And this disease because of trisomy 13. That means in his cell, one more 13th chromosome. Look like this. 1, 2, 3, 13 chromosomes. A lot of symptoms. Why? Chromosome disorder always have a series of phenotype. Why? Because a lot of gene located on one chromosome. If chromosome aberration happened, including a lot of genes changed. First, physical characters and a lot of organ defects, and also mental retardation. Look at these pictures. The baby always with small eyes or no eyes. Small eyes or no eyes. Very low set ears. Low set ears. In hair lip, like this. This is the featured appearance. Roca foot. The bottom of the foot like the chair, like this chair. Also a lot of defects. Heart defects, spinal defects like this one and that one. Spinal bifida, and also kidney disease and another organ defects. Mental retardation with very low IQ, incomplete brain development. So 99% cannot survive, cannot be born. And when they were born, 82 to 85% cannot survive past 1 month of the age, and 55% cannot survive past 1 year of the age because a lot of organ defects and very low IQ, mental retardation. This kind of disease is because of chromosome aberration. The diagnosis is very easy. We can do chromosome analysis for the patient. And in your lab training, you will do chromosome analysis by yourself. And sometimes from the blood of volunteer for you, and sometimes for the culture cell in our laboratory. But no treatment, because a chromosome, there are a lot of genes on a chromosome. So what can I do? What can we do? We cannot change the chromosome, cannot change the gene, but we also cannot do something for the symptoms. Too much symptoms, too much phenotype and defects. Multifactorial disorders. Multifactorial disorders is because of both gene and environmental factors. In the beginning of the class, I showed a picture of conjoined twins and rickettise. They all because of this reason, and the other defects like hair lip and spinal bifida are all because of this reason. Because of the environmental factors, made the key gene of development changed. Also, we know the diabetes. You know, yesterday or the day before yesterday is the Diabetes Day. Do you know it? And let the people to know some knowledge of diabetes, how to prevent diabetes, how to help the patients. Diabetes is a multifactorial disorders. In my family, we are a diabetes family. I can draw the pedigree for you. My grandfather, diabetes. But died already. This is my mother. One of my uncle and one of my auntie are diabetes too. In my father's family, my grandfather and grandmother are okay. But my father, what does this symbol mean? Died already. But my father is a patient. How about my risk? High, because both in my mother's family and in my father's family has history of diabetes. And 1, 2, 3, 4 persons in my family has diabetes. And my father's diabetes, and my father and my grandfather are very serious. They should use insulin every day before lunch and before supper. But this is the question of polygene disorder. Multifactorial disorders, another name is polygene disorder. Why? In this family, my mother is okay. His father is a patient. My mother is okay. And in this pedigree, my grandmother and grandfather is okay, but my father is a patient because of polygene disorder. Nearly 100 genes are reported related with the diabetes, with the mechanism of diabetes. But we call it minor effect genes. Each gene's effect is small, but the aiding. If you will be the patient, the first is how much in mutant gene do you have? The The second is the environmental factor. So not only the business of gene, but also environmental factors. Can you tell me the reason of the factors for diabetes? Continue. Who can ask my question? Do you know the environmental factor of diabetes? Too many glucose. Do you think fat is a factor? Yes, it's the most important factor of diabetes. My father is very fat. He can't buy clothes in China. When we sail to another country, to travel to another country, to West country, that is an opportunity to buy clothes for him, because very fat. So fat can make the receptor of glucose, receptor of insulin insensitive. Okay, so insulin cannot work normally. This is the factor. And unhealthy food. How many students came from US? Or do you think US food is unhealthy? Big Mac? Big Mac? Everything fried in oil. Okay, do you think it is? And too many. You get too many. So US people, always very big guys, everywhere. It's dangerous because fat is the most important factor of diabetes and unhealthy food. And the fat people always do not like sports. Always sit, lie down with the computer, always like that. So we cannot change the gene. I said again and again. The gene, the diabetes suspected gene from your father or from your mother, you cannot change it, but we can change the environmental factors. Live a healthy life. Eat some vegetables, eat the milk, the healthy food, and sports. That will be healthy. That will be make you low risk of diabetes. This is multifactorial disorder. And the fourth is somatic cell genetic disorders. It is always cancer. It always say cancer. What's this? You know, single gene disorder and polygene disorder and chromosome disorder is from your father and mother, from the father and mother. So the baby was born, each cell with the gene, with the mutant gene or aberrated chromosome. But somatic cell genetic disorder only in some organ, some tissue. Like this picture, cancer, tumor. The change, the gene mutation only in brain, not in every cell, or every cells, each cells in your body. The last one is mitochondrial disorders. Do you remember mitochondria? You have already learned cell biology. Mitochondria is the structure which has what? DNA, which also has DNA. So mitochondria is a special structure in the cell, has DNA, RNA, can finish the replication and the transcription and produce protein itself. Because mitochondria has its DNA, we call it empty DNA. So also mutation can happen on empty DNA and disease appear. Look at this picture, this table. This is mutation mutation location. And this is the gene's name, and this is the disease phenotype, disease name. How many students know Chinese? Okay, if you know Chinese, what do you found? What do you found? The disease always about muscle, heart. Okay? Like this, 心肌病, heart and muscle. 疾病, muscle. And the brain. Why? Who can tell me why? Do you remember the function of mitochondria? It's power factory of a cell, energy factory. So mtDNA, the protein of mtDNA is all the protein which produce energy. When mtDNA mutation happened, the mutant gene produced the abnormal protein of mitochondria itself, and mitochondria cannot produce energy normally. Without energy, which kind of organ or tissue suffered much more? Just muscle, heart, because this organ, this tissue need more energy. Okay, it's the end of today's class.